Hi, I'm John. I'm not going to bother with my last names. They don't pronounce well in English. I'm here to tell you why Flutter is pretty nice. In my talk, I'm going to talk a bit about what makes Flutter awesome and a bit how it works under the covers. And the next talk by Vitaly is going to be more about how to actually build apps, building apps. So he's going to do a lot of live coding, so you'll be able to see how it actually works when you're doing development. If you have any questions, it'd be nice if you save them for the end of the talk. I think I'll have some bit of time left over, so just write them down and we'll go through them then. So first, I want to take you a few years back to the days when Gangnam Style broke the view counter on YouTube, or as I remember it more fondly, when Peter Capaldi debuted as the Doctor. It's the year 2014, and there's a team working on a product at a pretty large company, and they have a thought that what if we take the basic technology from this product and we strip away all the requirements of legacy. So they start chipping away at this technology, the technology that actually renders stuff on the screen, and they aim to make it faster. They start chipping away. They remove HTML support. They remove CSS support. They even remove JavaScript. And at the end, they end up with something that's about 20 times faster than what they started with. So they're pretty happy with this result. And over time, they start calling it Flutter and make a fancy logo, because that's a requirement. Now, Flutter uses something called Skia. Skia is an open source project. It's a 2D rendering engine that's used by Chrome to render web views. It's also used in part by Firefox, I think Opera, and a lot of other apps use Skia to render 2D graphics on screen. It's really, really powerful. And Flutter uses Skia for everything. So whenever you're rendering like a button, an image view, a list view, whatever, Flutter uses Skia to render that. So there are no calls to the native controls on the native platform. So no calls to iOS UI table views or recycler views on Android. My initial reaction when I heard that Flutter does everything on its own, it renders everything on its own, it does virtualization of large data sets on its own, I thought, well, that's nice, but it never really works. It always ends up being a bottleneck, or it's not as well implemented as it is on the native platforms. Well, with Flutter, it actually works. And for the rest of this talk, I'm going to explain to you why it works. And in the next session, you're going to see how it works. So first, when we start developing mobile apps, way back when, or mobile apps for new smart devices, it was all about making them look and feel like native apps. You were supposed to make an app and it was supposed to look like it belonged on iOS. It was supposed to use all the native controls as they were designed by Apple. And the same goes for Android, sadly. But over time, there's been a shift towards making more personalized apps, making apps that look like something that's branded to look at something that's yours. So take, for example, apps like Facebook or Instagram. They don't necessarily look exactly like iOS apps, nor do they look exactly like Android apps. And Snapchat in the front here, they're doing their own thing. I mean, this doesn't look like anything else on the native platforms. But it's really recognizable. And that's what companies want these days. They want something that looks like it's theirs. It has their branding. And Flutter makes that much easier. So when you start off with a Flutter app, you start off with something that looks like material design, which is used on modern Android devices. or like iOS design, the new minimal design of iOS and iOS 7 and beyond. But going from that default or initial design to something that's completely your own is very easy. That's what Flutter was built for. It was built to customize the default design to make it something your own. Here are some of the showcases that Flutter had on their official site. These are completely different apps, fully built with Flutter, and as you can see, they have some inspiration of the native platforms, but they still look very distinct and their own. And all this is done without making any calls to native controls. This is all rendered with the 2D rendering engine, and it's actually made quite easy. Flutter is divided into 4 layers. I know there are more than 4 layers here, but they're kind of bunched together. And at the top, you have the material or Cupertino layer, which is the design of the material design or the iOS design. They didn't call it iOS or something, Apple or something. I guess it's copyrighted, so they went with Cupertino, which is it's where Apple's headquarters are located. So if you use the Cupertino material design in your app, it's as basic as just swapping out a few libraries, and it basically just changes the view or the design of the whole app and how it looks. And most of the code you write will probably depend on one of these layers, or both if you want to compile 2 different apps for the different platforms, if that's your thing. And right beneath that, we got the widgets layer. Now, widgets are the basic building blocks of Flutter. So everything you render on screen is going to be a widget. If it's a text view, an image view, or a list view for that matter, it's all widgets. But that also includes things that might not traditionally be considered a view. For example, if you want to add padding around a view, that's actually a separate widget. It's a padding widget. So there's a widget that has the only responsibility of that widget is to add padding to your elements. It sounds really strange when you first start working with it, but it's actually really nice when you start getting used to it. So that's you'll probably see more of that with in Vitaly's talk afterwards. Below the widgets layer, you got the rendering layer. This is the layer that's responsible for actually producing stuff on screen. So this will draw everything on the canvas. It'll composite it, it will animate, it will rasterize, and actually put it on screen. So that's its whole thing. And it also does gestures, as it says in the box to the right there. And below that, you got a foundation layer. And this is the most basic layer of Flutter. It provides runtime APIs. It enables you to actually draw on the canvas or draw on inside the app. It also provides some access to different basic APIs, like you might need access to the web for some reason. And that's the foundation. It provides those kind of APIs to you. Everything you do in Flutter is written in Dart. Now, Dart is not a very well-known language. And I'm going to take you a few years back again. This is the year after everyone tried to pronounce the name of this volcano. It's Grythe. But I remember the year after this thing as the year that the Doctor went to America. Season 5 Doctor Who. It's 2011. And Google announces a new programming language, Dart. And they see Dart as a successor to JavaScript. This is the new JavaScript. It's better than JavaScript. And their hope is that every browser will implement Dart natively, so we can start using Dart instead of JavaScript. And the web goes, meh. So it doesn't really get any popularity outside of Google, but it's actually used a lot inside of Google to compile from Dart to JavaScript. And in 2014, the Flutter team picks up Dart and says, "Oh, this looks nice. We'll use that instead of JavaScript." And so, from that moment on, Dart goes through a long transformation that really kind of ended in August this year, 4 years later, where they've taken the whole language and evolved it to be used with Flutter instead of as an alternative to JavaScript. And they've done a ton of work actually to get it to a new place where it's a lot better than it was, and it works incredibly well with Flutter. It's basically designed to work with Flutter at this point. Now, as is a requirement with all platforms today, if it's a language or a framework, you need packages. That's where it's at, the packages. And Dart got packages. They have a package manager called Pub, and you can download packages. That's what it does. It supports both Flutter packages, which contain functionality specific to Flutter, and packages for general Dart programs. Thankfully, they're both very clearly marked which work with Flutter and which don't, because Flutter has some limitations, some features of the Dart language that it doesn't support because of performance reasons. So, but you're still able to very clearly see which packages will work with what platform and what technology. This is a really nice feature of the Pub Package Manager, or the website of the Pub Package Manager. They have a health rating of all its packages. It's the 57 you see up in the right corner there. And it's based on 3 metrics. The popularity of the package, which is basically how much is this package downloaded compared to other packages on Pub. And it also accounts for like automatic tooling that pulls down packages all the time. It kind of tries to normalize that number so it doesn't, some packages just don't skyrocket if they have if they're in a dependency, other packages depends on it. Then it checks the health of the package. It uses the official Dart analyzer tool and goes through the package's Dart code and see if it has any errors, if it has any warnings or any coding hints. And for each error, warning, or hint, it subtracts a bit of the score. So this package, for example, apparently has a very nice Dart code because it has a score of 100. But it's not very much used, so they've only got a popularity score of 31. But then there's the maintenance score. And this is a score that is calculated based on how recently the package was updated. Are all the dependencies of the package up to date? And does it have the recommended files in its repository? So for example, does it have a README? Does it have a changelog file to show you the changelog? And if it does have all these things, it will have a full score. So apparently there are some things that are not updated in this package, so it doesn't get a full score. So the total score is a 57, but it also marks it as a new package. So the reason they might get a low score is because it's pretty new. There's not a lot of other packages that depend on it, and it's not really popular yet. So when you work with Dart and Flutter, it takes, whenever you compile your code to production code, it compiles down to machine code, our machine code. So it's running as native code on the platform. It's native libraries directly on the platform. That means that you get very, very efficient code. There's no layering between. It's basically just decoding straight into the CPU of the device. I say compile to production because when you're working with machine code, it usually takes a little while to actually compile that code. And that wouldn't be very efficient in a development environment. So what they do in development instead is that when you deploy the app to a simulator or an emulator or some kind of other device, it actually ships the Dart VM, the virtual machine of Dart, onto the device. And when you start the app, it starts up the VM. The VM reads the Dart code and compiles it and makes it run on the device. And whenever you make changes to your code, you save it. The tool chain will compile the code. It will ship it to the device or emulator into the VM. The VM will will then swap out the old code for the new code, and then continue to run the app continuously. So this is a feature they call hot reloading, and it's basically the same as hot module reloading that you've seen with Webpack and JavaScript. But it works here too, and they're able to do it really quickly. Usually it'll take less than a second from you hit save to the new code is running inside of the device. Usually like 200 milliseconds or less. So here's a quick example that I just stole straight off the Flutter site. He makes some changes in the code to the left. This is in Visual Studio Code, excellent plugins. And it updates on the right inside the app pretty instantly. In this demo, he actually hits the rerun button at the top. That's because it's an older version of the plugin. The newer plugin just does it whenever you save. So as I said, they have excellent plugins for Visual Studio Code, for Android Studio, and for IntelliJ. The tooling is really, really good. They've spent a lot of time making the tooling really good because they realized basically at once that we need really good tooling to get people to use this at all. They're late to the party, they need good tooling. So they spend a lot of time working on tooling. And what you get in the plugins is syntax highlighting and code completion. You get some code templates to insert code. You get hints of how to write better code. You get profile tooling to make profile the performance of your app. You get fancy graphs showing how much resources you're using. You can inspect the visual tree. So you're able to, basically what you do in the browser where you right-click a button, for example, and it says inspect element, and you see the whole HTML thing, and you can edit values and change stuff live. You're able to do that in Flutter too. They just built that because that's cool, but that's really nice. Whenever you're looking at the visual tree in Flutter, you're looking at a widget. Widget is the basic building block, as I mentioned before. Everything is a widget. Text views, image views, list views, widgets. Padding, that's a widget. You want to show stuff in a row, like in a flexbox maybe, in the one after the other, or maybe UI elements on top of each other. That's widgets. That's a row widget or a column widget. If you want to stack views on top of each other, that's a stack widget. And the widget thing goes all the way to the top. So the whole of your app, your actual app is just a widget. So the class myApp is just a subclass of a widget. And the nice thing is that this mindset goes both ways. So while everything is a widget, it also means that everything that contains any children also takes widgets as their parameters. So for example, the column, to stack the UI elements on top of each other, it takes an array of widgets. The app bar at the top of the app, the title part of that shows, for example, some text, it just takes a widget. So it might be a text widget, it might be an image, or it might be a 2D game with realistic physics. It doesn't really matter, it's a widget. So Flutter just does whatever the widget does. There is actually a package that is a 2D game engine that is a widget to embed inside of your app if you want a minigame for some reason. Flutter is designed with a unidirectional flow. So this is basically what React does. You have some user interaction. You change some state based on that interaction. It might be the user typing in a text field. So the user types a new character. You update the state, there's a new character. You tell Flutter, there's been a change in the state. Please re-render this. Flutter reads new state and generates new widgets based on the change. And then it re-renders the thing on the screen. And then it takes the existing view that's on the screen and it compares it to the new view that's been rendered after the state change, and then does a diff to see what changes are needed to update. So again, just like React does. They just copied the idea. It was a good idea. So for example, if this text area down here and the left corner changes, Flutter will try as best it can to only change that part of the app. Because changing the whole visual tree, this is a really simple one. It's basically nothing. This is not much of an app. But if you have a really complex app with a very, very deep nesting tree, it's not very efficient to change the whole tree every time something changes in your app. So Flutter will try to intelligently locate the part of your app that has changed and only change it, maybe its parent, and most likely its children. But not necessarily. It kind of depends. Flutter does this as well as it can. Sometimes you have to help it along a bit, but in most cases, 9% cases, it just works. Another strategy it uses to actually make these updates more efficient is, if you have a red square, for example, and you want to swap that out for a block of text, that's two completely different things. So Flutter has to jump down to the rendering layer, below the widget layer, and swap out what that box for a block of text. That's two completely different things for the Flutter rendering engine. But if you have a red square and just change the color of it, for example, to blue, that's a simpler operation. There's no need to create a whole new box or a whole new square that is blue. Just change the color of that one to blue. That's a lot more efficient. So that's what Flutter does. It just changes the color, because that's more efficient. It allocates less objects in memory, and it's faster when you're actually doing the rendering. And speaking of all this code, as I mentioned, you're writing dark code when you're writing in Flutter. And this is what a visual tree usually looks like when you're writing it yourself. So at the top we have the scaffolding. It contains an app bar. It has a content view in the middle, a body view. And it might also have a floating action button like you see on Android or the new Twitter app apparently. And a bottom bar also if you want. It's completely optional to use, but it makes a great layout for your app. Then you have an app bar at the top with a title. It takes a text widget. The widget takes in some text to show. There's a center, which centers something in the middle of its parent. There's a column, which stacks things on top of each other. And then there's two text elements. You push the button this many times, and then a counter that displays the counter text. When you first start working with this, it looks really chaotic. I remember back when I first saw slides of view trees in Dart, and I thought this is really complex to read. I mean, I've been working with like XAML or Android XML, and that actually looks better than this, I thought. But then when you start working with it, you get used to it, and then you actually start liking it, and then you're on board. Then it's too late. Flutter lives in its own kind of bubble, its own Flutter bubble. So everything happens inside of that bubble. And that's the Flutter app on the left of this graphic. So it contains the whole app. Everything, UI, your state, whatever happens. But sometimes you need to do something on the platform. It might be reading or writing to the disk. You might need access to the camera, or you might want to know the GPS location, for example. You need that way to communicate with the native platform. And this is done through the platform channel, which the method channel is a type of platform channel. And it's a two-way communication channel for the app, your Flutter app, and the native host app to talk to each other. It goes both ways. It's really, really efficient, basically because it needs to be, because it's how Flutter internally also talks to the native app. So whenever Flutter needs to show a keyboard, for example, on screen, it sends a message through the platform channel to the native app to show the keyboard, please. And then whenever you input characters, it sends those characters through the channel to the Flutter app, so the Flutter app can actually show them on screen. So they're really good. You can of course make your own if you need to implement some native part of the platform. For example, if you want to know the battery level, you can make a platform channel to send that back and forth. before you go implementing a lot of things yourself, there is a lot of packages on pub already that enables you to access native resources. For example, writing files, accessing permissions, for example. There are already packages that does that for you, so have a look at those. To get started with Flutter, I really recommend staying for the next talk. That gets you started with Flutter really fast. If not, I recommend Flutter.io, their official site. They have really, really good docs. They have an excellent Get Started section, which takes you through the programming language. They have a really nice language store, which basically tells you how that works. If you work with JavaScript, Java, C#, or any C-like language before, Dart is going to be really familiar. I mean, they just copied ideas from all over the place. So that's really easy. Some small features that are unique to Dart, but nothing big. They have a really nice getting started section that also includes building a couple of apps with Flutter, simple apps to get you started and kind of get the feel of how things work. They also have, the official docs are at flutter.io/docs. But then they also have the API docs, which are at docs.flutter.io, just to keep it simple, I guess. And the API docs actually have a lot of great information. Usually API docs may be a bit sparse in frameworks or in libraries in general, but the Flutter API docs are really comprehensive. I had a look at the column, the API docs for the column class, which stacks UI elements, and it has an explanation of what it does. It has some sample code of how to use it. It explains the algorithm it uses to how to lay out the elements, and it even has a troubleshooting section if you can't get it to work correctly, all inside of the API docs. It's really, really comprehensive. Luckily, the search box on the top right there, it searches everything. So if you have a problem with a widget, just search for the widget name, and it probably will show you the best results. It's based on Google search, believe it or not. And one nice thing is, Flutter is really just a view inside of your app. When you create create a new Flutter app, it's basically just, for example, an iOS app, and there's just one view controller inside of it, and that's the Flutter view controller, and it contains a view, and that's your app. That also means that it's actually quite easy to embed Flutter inside of an existing app. So if you already have an app running today in production that you don't want to redo the whole app now, but you want to get started with Flutter, you might, for example, start working on a new feature might be implemented in Flutter and embedded inside the existing app. And then it can just kind of expand and take over the whole app from there. As the last thing, I just want to show you, like, creating a new Flutter project. Vitaly is going to show you this a lot better in the next section. Next section. Let's see if I can get this working right. I have been testing. So I'm going to be typing everything wrong now. So to create a Flutter app, it's quite easy. You just write Flutter, create. Let's call the mobile layer this time. Oop. So it just pulls down a lot of dependencies from the SDK, and then it runs Flutter packages get, which is, it downloads all the dependencies. It's not really that many. Oh, yeah, that's good. Oh. Here's to hoping it does not crash. This worked, of course, when I tried it like an hour ago, but now it won't work, probably. And it's apparently not working. That's fine, because I prepared for this eventuality. Never trust the demo gods. I have this back to a project. Just put this over here, not that one. I did the wrong thing. Oh. Look at you struggle with macOS. Here we go. Wow, that's really big. Let's try one of these buttons. Someone in the audience, tell me what I'm looking for.
You can go to hardware.
Yes.
Device. Select button is small device if you want.
Isn't there one with a scaling thing though?
You can just resize the window with the mouse.
Oh.
You get the corner, it's not so easy to do.
Ah, there we go. Hey! Is that a new thing? I can't remember that being possible in the previous version of it. Anyway. Oh, okay, thank you. Here we go. And of course it's not working now. Okay, so everything is working against me today. Well, at least here's the project. You got a main.dart file. It contains code. It's a simple app. It contains a main method, which is run when the app starts. It runs my app, and my app just extends the stateless widget. And this is the root of the app. And if we can get this working, the nice thing about the tooling in Visual Studio is that I can just go here, press play. Oh no! What is it doing now? Why is it? It apparently thinks it's in .NET for some reason. Okay, so nothing is working, which is of course exactly as I planned it. I was going to show you, it's just a simple template that they have when you start, okay, everything is not working out. I was just going to show you the simple app, which of course won't work now. It's just a simple app, you hit a button and it increments a counter, and it's really easy when you just switch out the code. What I really want to show though, too, is the sample UI test they actually include. So, you start by pumping a widget, which is basically you make the UI render. So first you just start by newing up the app and pumping it, which is basically inflate the whole app. Then you expect to find a 0 and not find a 1. Tap the button with the add icon, then pump the app, make it advance, make the UI advance, and then check that there are no zeros and there is one number 1. And usually this test will succeed. Well, we can actually try and see if it works, because everything else does. Flutter test. And it worked, yeah. So that's the only thing that works apparently, testing. But it's the most important part though. So UI testing is built in from the bottom, so from the start. So the Flutter team knew that UI testing is going to be essential. It's really a hassle to do on all the other platforms, and Flutter just supports it natively because testing. That's basically all I had. Any questions? Yes.
Just give me a second.
He's going to bring you a microphone.
Thank you for the presentation. I was just wondering, what's your sense of how responsive Flutter is to changes in the platforms? Like when Android or iOS changes, what's the lag time before it's supported in Flutter?
Are you thinking of like visual elements or more platform?
Like APIs, stuff like that?
Ah, okay. Most of the platform APIs that would usually change would be implemented via one of the via platform channel.
Right.
So usually it would either be Flutter don't usually include those in the SDK. They're usually packages. So you can either implement it yourself. If you know how to do it in native code, you can use Swift or Objective-C or Java or Kotlin. You just decide whenever you create the project what kind of language you want to use on the native platforms. And as long as you're able to implement it in the native code, it's really easy to make that work with your Flutter app.
Right.
The messaging thing is really simple to get started with. It's probably like 15 lines of code to make it work.
And a follow-up question. Is it easy to interrupt and add native code, like a chunk of business logic in Android? Or?
Yeah, I can actually show, for example, in, let's take the iOS because it's, this is the, it uses Objective-C as the default language when you ever create a project. And in the app delegate, this is the implementation. Basically what it does is launch the Flutter view inside of here, but you're able to register your own code inside of here. So if you want to, for example, do some TensorFlow or ML on the platform, which is really platform specific, you implement it as you would usually in, for example, TensorFlow you would implement as you would, normally would on Android. Following all the tutorials on the web, that's the nice thing. You can just use the regular tutorials. And then when you need the results from your calculations inside of your Flutter app, you just pass it through the platform channel. So you'll have a handler inside the Flutter app that says whenever there's a new message, do this thing. So it kind of works like it works basically like a socket or a web request. So you send a message and you wait for a response, most likely. And it's all synchronous and it works.
Hi. Yeah, I really like the sound of this. I always thought that just manipulating the view hierarchy directly is kind of the holy grail.
Yeah.
Dealing with parsing HTML and all that. But like for instance on Android, if everything's kind of wrapped in its own little bubble, do you just ditch the whole activity fragment hierarchy? And
Yeah.
Just
all of myself. On Android, I think there's just one like main activity, and that contains a view, which is the Flutter. I think it's just named Flutter view, and it just renders that, and that's it. That's all the Android app does by default.
So if you wanted to, like, I assume it's good, if you wanted to do like a view page with tabbing and things and move between screens, is that functionality given to you by Flutter?
Yes.
So a view page will allow you to flip between screens and load data.
Let's see if this is a really nice service, by the way. I was supposed to show it, but I forgot. It lets you paste in JSON and it generates classes for you, and it even does the code to convert back and forth between JSON, which is really nice. Let's see here. /docs. They have a really nice widget catalog, which shows you all kinds of widgets that's included. Included the material widgets, which include a lot of things. And somewhere down here, there is such a view pager or like a carousel, which I'm probably just going to scroll right past the first time. Yeah, I'll scroll past it probably, but it's in there. I've used it.
They've kind of replicated all the components.
It's actually quite funny because Flutter actually implements material design better than Android does at this point, because it's so difficult to do on Android, but it's really easy in Flutter.
Yeah, thanks for the presentation. When and why should I use Flutter over React Native?
It depends. It might depend on the use case. What I've seen some React Native devs say when they jump ship from React Native to Flutter is mostly performance reasons, especially in regards to animations, which sometimes I haven't worked with React Native myself, so I'm basing this on what other people have told me. And sometimes animations can get stuttery using React Native because of the limitations and bandwidth limitations between the JavaScript environment and the native environment. Flutter's moved everything, all the rendering things over to the Flutter side, so there's no bandwidth problem there. They try to communicate as little as possible with the native platform and keep everything internally. And since everything is compiled down to machine code, you'll also get really high performance when you run the app in production mode. So that might be some of the reasons you might want to change. Flutter is not yet in version 1, so there are still some things missing. So in some cases, React Native may be a better alternative, but let's be honest. But so far, Flutter is looking to be really good when it's properly finished. There are already apps running in production, actually. Yeah, they actually have a section section here which explains the difference between Flutter and React Native and some performance on iOS and Android and web. So if you're transitioning from another platform or framework, those are actually quite good. They're written by the community from devs actually switching from other solutions to Flutter. They also have this showcase page which shows some of the apps using Flutter in production today. Yes?
Thank you for the presentation. I actually kind of answered the question. I wanted to differentiate or compare between navigation libraries in Flutter with the React Native.
Mm-hmm.
Because in React Native navigation, sometimes you have, so they have React Native Navigation 2 library, which you normally usually use for navigation when you put the top bar, bottom bar, or that kind of stuff. But I guess you have in Flutter built in. Do they have in the pub that somebody?
Yes, they have a routing widget because everything is widget, and that routing widget can either you can either just apply new views to show as a new page. Basically, there's no difference between a small view and a whole page. It's all just a widget, so you can pass it basically anything to just navigate to this button, for example, and it will try to navigate to the button. It doesn't make a lot of sense, but it tries. So you can just apply new views to show, and it will transition to those new views based on the platform it's running on. So if it's running on iOS, it will try to simulate the sliding feature of iOS, and on Android it tries to do the Android transition instead. But those are just implemented as callbacks, so you can actually change those as you want if you want some kind of crazy navigation animation in your. But routing is built in, and it supports both just navigate to this view, or you can set up named routes. So you can, almost like a web page, and say, if you navigate to the /about route, you will get this view. That also makes it easier to support launching, like launch strings from a web page, for example. You can say, have a URN that's /product/ID, and it'll actually just be a route inside of your app. Yeah, the deep link vector. That's the word I was looking for.
The overall experience is really good then. I mean, better than. I mean, I wanted to compare to the React Native, but you said you
I haven't done any React Native. I'm seeing a lot of people being really happy with Flutter, especially with the tooling and the performance. It's really good. I've only had one issue with the tooling, and that was because of a dependency I had. So it wasn't really my fault or the Flutter's fault, it was a dependency.
Okay.
Hi. Does Flutter work on web? You make web apps with it?
No, it's only iOS and Android so far. And well, iOS, Android, and Fuchsia, Google's new operating system. But they don't have any plans for any other platforms as of yet. But I've seen a proof of concept of it running on Linux. But the problem is basically that you need something to implement all the API that Flutter requires to run. And I won't say it's impossible. I mean, everything that can be implemented in JavaScript will be implemented in JavaScript at some point. So it seems like a big job. So I don't see. I can't see that working in anytime soon. But what I know some companies are doing is that they basically just standardized on Dart instead. So they use Flutter on mobile, they're writing Dart there. They use Dart on the server to as a web app, and then they use Angular Dart for a spa on the front end, and that makes you able to share a lot of the logic and a lot of the models between all the different platforms. So you only implement the UI on web and on mobile, and the rest is basically just shared.
No tool is perfect. So,
No.
for you personally, what has been the biggest pain points so far?
The biggest pain points. Before I started using QuickType, it was JSON. Because JSON is everywhere. And Flutter doesn't support reflection or introspection. So, because it's not, it's too much of a performance hit. So, you have to do all the converting between your classes and JSON manually. The QuickType does that for you, so that's nice. Before that was a really pain in the bottom. And also there are some let's call it limitations right now when it comes to storage. So Firebase has a package for Flutter and for Flutter that works automatically, so you can sync against Firebase, but other databases are still in the early stages. So if you want some kind of complex database to run locally on your device, it's still kind of weird with Flutter, because you need to have a platform channel and communicate back and forth when you want to do writes and reads. So that's the most annoying thing so far for me, at least. So if it's okay to use Firebase, it's excellent. But if you're going to do anything else, it's a bit of a hassle. Any more questions? I'm just going to say no before anyone.
No, I have a question. How do you see the future of Flutter? So we see sometimes Google push a lot of projects. This kind of project, and then after a while, it's just gone.
that is very true. Personally, I think Flutter has kind of unintentionally, but I think now it's part of a master plan of Google's actually. Because some of you might know that Google has a new operating system in the works called Fuchsia, which is, I guess, the successor to Android or something. But it looks like they're going to push a new OS in the next few years. And the problem with making new OSs is always there's going to be an app gap. You're going to be missing a lot of apps. Flutter, however, is actually the native way to build apps on Fuchsia. So if you have a Flutter app working on Android and iOS, it's probably going to be very few changes to make it work on Fuchsia. So I'm guessing this is their way to get people starting to develop Fuchsia apps, and when they release Fuchsia, they can just transition them over pretty seamlessly. They probably won't make Facebook and Twitter do this, but it will mean that they will get a lot of apps all ready to go when they release their new OS. So I actually think it won't disappear. And as I mentioned, it's already started being used in production, and the community around Flutter is very, very good. It's very active. There's a lot of people coming in, and if nothing else, it's open source. The community would continue maintaining it, if nothing else, I would think.
One quick question. How different is it from JavaScript, and what's the learning curve for Dart?
Okay, so the question is, how is the learning curve coming from JavaScript to Dart? It's very, very easy. I mean, it was originally designed to be a successor, so it kind of borrows a lot of things from JavaScript. They have a lot of extra features that JavaScript don't have, but Dart mostly works as you expect. So whenever you write JavaScript code and it doesn't work as you expected, Dart probably would. But the learning curve is very, very, it's not very steep. It's quite easy to transition over.
Just like the demo.
Yeah, sure. It's like the demo. Okay, I think
No more
that's it.
question? Great. So on behalf of Mobile Area, I have a gift for you. Thank you for the nice presentation. So hope you
thank
enjoyed
you.
this gift. And thank you for being here. So
See you for the next one.